Alright, so section 3.0, we're calling this, is about solving equations when your variable appears on both sides. Both sides of your equation, that means you have your equal sign, and then to the left of the equal sign you have your variable appearing somewhere. Maybe usually it's x, but then it also appears on the right side of your equation, to the right of the equal sign, which I guess maybe I should have showed you this as I was just saying that. So here we have our left side of our equation, and look, we have an x variable right there, and this whole part is the right side, and we also have an x over there, and we're trying to solve for it. So earlier in this, like last chapter or whatever, we were just getting the variable all by itself on one side. So I mean, how do we do that? Like, what does the process include when we're trying to get x all by itself, but it appears on both sides at first? Well, let's kind of run through some notes here, some examples. If you have a variable on both sides of your equation, left side and right side, you must add or subtract one of them to get both variables on the same side. So you're essentially going to be like moving one of them to the other side by doing the opposite. So let's see that in action. Okay, so we have on this side we have a 5x, like 5 times x, and then over here we have a 2x, or like 2 times x. We want to move one of these to the other side so that we only have x on one side. And then this hint down here, as a general rule of thumb, this is not something you have to do, but if you want fewer negative numbers to work with, then the one we're going to move, like, how do we decide which one we're going to move to the other side? Well, a lot of teachers say move the smaller one. If you move the smaller one, which you don't have to, but if you do that, you'll end up working with fewer negative numbers in your steps. So let's kind of go with that. And the smaller one is the 2x. So in order to move the smaller one, we do the opposite of it, like that. This is a positive 2x. So we subtract 2x from both sides. So we're going to move it. There's not going to be any x over here anymore. And then over on the left side, it becomes 3x. 5x minus 2x is 3x. This minus 2 just drops down because it was on that side. And then on the right side, with this 2x being moved, the only thing over here now is the positive 1. And now we continue like normal, like we kind of did last chapter. Now that we only have x like appearing one time on one side, now we can work on getting that x, that variable, all by itself. Like, we don't want this left side to say 3x minus 2. We want it to just say x. Like, we want to end up with x equals whatever, and that's going to be my answer. So just like last chapter, we would now add 2 to both sides to kind of cancel that out. And so now the left side is just going to be the 3x, but now the right side's 3. And then how do we cancel out that 3? If it's 3 times x, we have to do the opposite, which is dividing both sides by 3. So my final answer here is x equals 1. So a lot of this was just things we've already done, last chapter. But first we have to get the x only to one side. So now what we're going to be doing like a bunch of examples, right? And I invite you to, pause the video now and then to try it for yourself, or at least think of how it's going to start. I'll try to give you some think time as we look to start each example or go from step to step, but you're more than welcome to pause. I mean, it's a video, of course. You can pause, you can re-watch, whatever. Go back and watch certain parts again, but alright, so we have over here on the left side we have an X, and over here we have an X. So we have to move one of them. So if we're moving the smaller one, we have to do that first, which makes the left side now 1x. Technically this is a 1x, and then the minus 2, and now the right side is just 4. And then now we're able to now get that x all by itself by adding 2, which is the opposite of subtracting 2, to get x all by itself. Okay? So nothing that different there. Similarly here, not going to be too much different. I mean, but now if you were following the rule of moving the smaller one, see, you can, you're more than welcome to move this 5x over to the left side. You'd have to subtract it. So if you're following the one rule of thumb where you're moving the smaller one, then you're going to move this one over to here and end up with this, because 5x minus 3x is 2x. But now you're in the situation where you're going to be getting x by itself on the right side, which is fine. We're going to be adding 21 to both sides and then dividing both sides by 2. Okay? So again, a lot of this is repeat moves and steps from last chapter. This first step is really the only new thing in this class that we haven't really done yet. Okay, this is interesting. If we're going to follow the, moving the smaller one rule, which one's smaller? Negative 7x or positive 5x? Well, I'm hoping you're looking to move this one. You don't have to, but if you're going to move a negative 7x, like what cancels out a negative 7x so that we can move it away from the left side over here? We have to add it. So adding that cancels out that, and then the left side is just going to be just the positive 10. And then what's the right side going to be? Isn't that going to be positive 12x, and then this minus 2 drops down? And then again, from here on out, now you're just doing whatever you have to do to get this x all by itself on this right side. So again, to do that, first you would add 2 to make that subtracting 2, gone. And so that would leave you with a 12x over here. And the left side, of course, would now become 12. And then if this is now 12 times x, the opposite of that, to cancel it out and just leave x, left standing, is to divide both sides by 12. And so you end up with 1 equals x, which, that's fine. The answer is 1. The solution is 1. Doesn't matter if your final equation says x equals 1 or if it says like this, 1 equals x. I don't think there's too much here. Which one's smaller? This is really 1x. And that's negative 3x. So if you're going to move the smaller one to get x only to one side, you'd be adding, because that's what's going to cancel out, minus 3x. So the right side is only going to be the, see, that's a negative 14. And then over here we're going to have, if 1x plus 3x, 4x plus 2, right? And then once again, now you're just going to work on getting that x all by itself by doing that. And then again, negative 14 minus 2, that's minus 16. And then of course we're going to finish by dividing both sides by 4, because that leaves the x standing left over, and that's when you're done. So negative 16 divided by 4 is negative 4. Alright, so here, this is where, if we're in class, like what we're going to be doing in class, if you weren't there or if you're missing it, we're probably going to stop here for you to do this 3.0 in-class assignment. So if you have that paper with you at home or wherever, you should pause now to do that assignment, okay? And then I'll continue the video after a pause. Alright, so the rest with the rest of the examples, kind of running through what you should kind of do if the equation's a little bit more complicated, if there's more types of steps that are going to be involved. So like looking at this first example, it's not just going to be a simple matter of moving one of the x's over. There's more things going on here to kind of unravel this and eventually just have x only on one side and then all by itself. So when you see parentheses to clear, that's what you should do first. So over here is going to be a pretty good comprehensive hierarchy of steps and what you should do first and what steps you should do and in what order. So whenever you have parentheses to clear, by distributing, like whenever you have something times a bubble or just any kind of set of parentheses, that's usually what you're going to want to do first. Do you absolutely have to? No, but I really think you should follow these steps religiously to the letter, okay? So before we move x's around to other sides, you're just going to want to distribute the 2 and clear the parentheses. So that's all we're doing in our first step. The minus x drops down, and then we are going to distribute the 2 times x, and then 2 times the minus 1. And then the equal sign drops down. This entire right side is still just 3x minus 8. That's all we've done, is we've cleared the parentheses, and that's what you should always do first if there are any. Now the second step, what should you look to do second if it's there? Well, look at this left side. Do you see how we have a negative 1x and a positive 2x over here? And over here, of course, we have the 3x, but we have a couple of x terms, a couple of like terms that are already on the same side. So if it's there, here's what you should probably look to do second. Combine like terms that are on the same side. That's we're not going to be moving them, okay? We're literally just going to do negative 1x plus 2x because they're already together on that left side. So negative 1x plus 2x, that just combines to make positive 1x. The minus 2 drops down. This entire right side just drops down. And now look what we have. Okay, it's getting a little simpler, right? But we still have a couple of x's, or we have an x on both sides. So we have an x over here, and we also have an x over on the right side. Remember, the equal sign is the thing that divides left side from right side. So next is when we're going to look to move any variable to the other side if necessary. And we just got done covering this, earlier in this video. And here I think we're going to be moving the smaller one, yep, to the other side. And so that's going to leave, change color here. So that cancels out over there. And so the left side is now just going to be the -2. Remember, it's really subtracting, it's really a -2. And then the other side becomes 2x, and then with the -8. And then now we're just going to make whatever moves that you have to do left over to get that x, that variable, all alone on that side. Which again, we've done this before. We're going to be adding 8 to get rid of that -8. So the left side now becomes +6. The right side is now just 2x, and then to get rid of that ×2, we divide to end up with a final answer of 3 equals x. Or x equals 3. The solution's 3. And it just popped into my head, so I might as well just remind you, as a general sort of, like, what does it mean to be a solution? What does this mean? If x equals 3 being the solution, that means that if you went back to the original equation and you replaced all of the x's with just 3, like literally -3 plus 2 times 3 minus 1 equals 3 times 3 minus 8, it would make the left side actually equal, like literally equal the right side. It would make this true. You'd have a true statement if x was actually just 3. Alright, a few more examples it looks like, but again, just kind of practicing this overall procedure of steps, So what would you do here first? You would clear the parentheses. If there's parentheses to clear, you do that first. Nothing done on the left side, but 2 times x, and then 2 times 7. So that 2 got distributed. Now we can move on to what? Like, what do you think is next? Are there any like terms that are already on the same side? No. But we do have an x over on the left side and an x, a 2x over on the right. So my next step is to do that. Which gets me to here. 2x minus 1x, essentially. 1x. And then what do you think is going to happen next? Don't we now just want to get that x all by itself? And to that we do the opposite to get rid of stuff. And so here the final answer is 5. The solution is 5. Again, pause the video as needed, right? So this next example, what is there to do first? And again, you don't have to do a particular thing first, but again, it's really, really recommended that you probably would just want to follow this general procedure. So are there any parentheses to clear? No. Nope, don't got to do any of that. Are there any like terms that are already on the same side together? Yep, right here. 5x, so you just do it as they are, as is. So 5x minus 6x is -1x. So that's all I did in that step. Now you move on. It's like now you just hit the reset button. So now it's like you're looking at this fresh, and thinking to yourself, what do I do now? What do I do with this? Okay, well, you have to look at this and see that there's an x variable on the left side and the right side. So one of them has to be moved. And, you can move either one, I guess, but if you're going with that rule of what? Moving the smaller one, what's smaller? Negative 1x or negative 3x? Well, this one's smaller, right? So what's the opposite of minus 3x? Adding. Like, that's what's going to make that gone, right? Keep in mind, I don't know if I've said it quite this way yet in this video, but negative 3x plus 3x is literally 0. Okay? So it's gone. And on the right side, you just have minus 8. What's the left side going to be? What's negative 1x plus 3x? 2x with the minus 2. And again, like, what? Now you look at this fresh. What do you do now? Well, isn't it now time to, move things and get x all by itself? Yep. So you add 2 to both sides to end up with this, and then you divide both sides by 2. And so that's the final answer to number 3. Pause if you have to. How about this one? What do you think we're going to do first? There's no parentheses to clear, like there's no distributive property. I see a couple of variables, but they're together on the same side. So just do them. Do 5x minus 2x. You don't have to move any of them to the other side. They're already together here, and they're just going to combine to make 3x. So now looking at this, isn't it now just as simple as, making sure that the left side doesn't say 3x plus 6, that it's just going to say x. So we have to get rid of the 3, and we have to get rid of the plus 6. And you should know which one we get rid of first. Do we undo this 3 first, or do we undo the plus 6? Gotta do this next. Then divide both sides by 3, and you get a final answer of x equals 2. Pause the video if needed, but moving on to number 5, which is, it's not the last one. There's 2 more. Alright, so what do you think we're going to do first? Remember, going back to these steps that hopefully you wrote down, and you're going to follow religiously. Isn't there parentheses that need cleared? We need to clear these parentheses on the left side, and then we also need to clear those parentheses. So distributive property, 3 times 2x, and then 3 times positive 3. Likewise over here, 5 times x, which is just 5x, and then 5 times the minus 1, which is minus 5, and then don't forget to bring down the minus 6 also. So what would you do next? Are there any like terms that are combinable, like already on the same side? Actually, yes. The minus 5 and the minus 6, negative 5 minus 6, you should just combine those. Again, do you have to? Like, can you get to an ending by doing something different next? Yeah, but if you're again, follow those steps. I think you should follow those steps. So that's my next step, and then again you reset. You look at this fresh. So what do I do now? Here you should notice that we have this x term on the left side, and then on the other side of the equal sign we have another x. We got to get them on the same side. So that's what's next. right? So now the right side is just the negative 11, and the left side becomes 1x plus 9. And now once you get to something like this, now you can just focus on getting this all by itself on this left side by doing the opposite of that adding 9, and then negative 11 minus 9 ends up with negative 20. So that's how that equation comes to a solution. Last example. I don't know if there's anything, again, just nothing new, just like a number of examples to kind of get you in the right zone here, get some practice. So what do you think is going to happen first here? Or what do you think we should do first? I mean, there's plenty of things we could do and not be wrong, like, well, but are there any parentheses to clear? No. Are there any terms that are like terms that are already on the same side? Yep, right there. And then next, you should probably notice that we have an x here, x there. So we're going to add x to both sides, moving this over here to make 3x plus 6, and the right side is now just 105. And now what? We can focus on getting this x all by itself on that left side by first canceling out the adding 6 and then canceling out the times 3 to end up with x equals 33. So final answer, the solution all along was that x equaled 33 to make this equation work. And that's it for section 3.0, variables on both sides.